What are the four golden signals and how can they help us get underway implementing SRE? Find out in a second. Welcome to Slope Reliability, the show about human beings and their experiences in SRE, observability, and technology leadership. I'm your host, Stephen Townsend. When you start an SRE practice, one of the first things you might be expected to do is to implement SLOs, service level objectives. SLOs are the backbone of SRE. It's the way that we connect reliability to business and customer, to shift our monitoring and alerting to be customer-centric, and to drive innovation through the use of the error budget. But many years ago, I expressed the opinion that there are prerequisites, things that if you have in place, give you a better chance at implementing SLOs. And as the years have gone by, I think I stand by that observation so far. The other thing about SLOs is that they require cross-team communication and alignment. And in the very beginning of implementing SRE, I think it can be helpful to find something that the SRE team can do themselves without any dependencies, to rack up some easy wins and to see the benefits of this kind of work. For me and my team right now, that early thing has been implementing golden signal monitoring and tracking availability. SLOs are the ultimate way to track whether your customers can consume your services effectively. But our stepping stone toward that is to tackle the question, is my service healthy? Perhaps it's 6 of one and half dozen of the other, and I'm certain what we're doing now is laying the groundwork for SLOs later. But bear with me. I'm about to share my real-world experiences moving from the paradigm of we log events to we measure signals, and how that mindset shift is helping us better understand whether our services are healthy or not, and really thinking about what healthy actually means in any given context. If you haven't heard of them before, the 4 golden signals are a concept from the original SRE book. They are a list of 4 things that if you monitor nothing else, you should monitor. The signals are latency, how long things take, error rate, the rate of errors, and arguably the detail of those errors as well, traffic, or the throughput or load on a service, and saturation of resources. Our approach has been that for any new service we deliver, we should be looking at the unique context of that service and figuring out for those 4 signals what makes sense to track and potentially alert on. For example, looking at latency, one service might be an asynchronous chain of processes, and we care about both how long each step in the process takes, but mostly how long the overall chain of events takes. But there might be another service, like a real-time API, which we specifically care about the latency from the consuming system's perspective. So while we're on that roll, let's start with latency. In Bluecurrent, the really interesting challenge for me is that the vast majority of our services involve asynchronous processing of events, like I just talked about. We're talking about files and transactions and processing that may occur over minutes or hours rather than real-time APIs or web interfaces, which would be looking at milliseconds or seconds potentially. In this asynchronous context, I've been thinking about a couple of things. The first thing is we need to be aware of the context of the service. If this is a thing that happens, say, once a day, there's often an SLA. There could also be regulatory requirements that this process needs to deliver data by a certain time of day or within a certain time frame. We need to know about those things up front because they help us define the criticality of latency for that service and what instrumentation or telemetry we need to track this effectively. As I've been suggesting, in this context, I think the most important thing is how long the overall process is taking. Then, if we can achieve that, a breakdown of the key steps of the process and how long they are each taking is helpful too to help pinpoint where any slowness might be. The second thing I've been thinking about is that with this async flow, it's not particularly conducive to the traditional distributed tracing. So when you have a file that's picked up and processed, and maybe that file has hundreds of transactions, which each get handled individually, and then those transactions might get bunched up into groups or into other files again later, and then maybe sent externally. That's not the traditional flow that tracing was set up to capture using trace context propagation. I think also from memory that traces need to occur within a certain time period, although there might be old information. So like what if an async job takes an hour to complete and that like one transaction takes that long to complete its full processing? I haven't looked into it yet, but I'd be surprised if an out-of-the-box trace, so using OpenTelemetry, could capture that. Although I'm pretty certain I'm about to be challenged by that after I release this. I'd love to hear more about that. The current pattern that I'm seeing to solve this is a solution within the design itself. So with each of these async services we deliver, there's usually some kind of data store or database which is keeping track of state. It's tracking for each transaction when it starts, when it ends, what are the steps in between, and when did they occur, and what is the state at any given point in time. So all the information that I need for latency is right there in that data table. It's just about finding ways to convert that into metrics that can be sent to our telemetry gateway or some other way of turning that into signals that we can track for latency. I do also want to say we do have some real-time services as well, and we're covering ground there, which I'm much more familiar with. Things like externally facing web portals, where we're most interested in the end user experience, and that's where browser monitoring might come into play, or leveraging synthetic monitoring, those kinds of things. So I am doing that kind of thing as well, but the asynchronous is the bigger part of my world and the thing which I think is more interesting at the moment, because I don't think as many people are thinking about it in the context of SRE. On to error rates. So I think with the rate of errors, the starting point here is to have a conversation about what constitutes an error. So I had an interesting conversation recently, a new service that's coming on board through a project. We had a discussion about technical failures versus rejected transactions, and how one is actually a normal business activity that we as SRE shouldn't be responding to, and the other is a technical event that does require our intervention. So going back to that async processing context, I think about what the processing question is doing. What's the big picture? What's the thing that it is trying to achieve? Maybe it's about reconnecting power in someone's house or just delivering some data to a customer. Whatever the goal is, the first thing I want to know is whenever this overall process fails and how much that needs to occur before we need to intervene as an SRE team. This is skipping ahead a bit into availability, which we're going to talk about later, but I've been finding that in this async processing context, that availability and error rate are closely linked. The next thing we've been exploring, and I have to give credit to my team for this, not me, is to start asking about known failure conditions. So for a new service, developers will have built in error logging for specific events or checks for things they know mean something bad has happened. Architects and business analysts will have built in deliberate handling of different failure conditions, or perhaps testers during testing uncovered unexpected failure modes that they can tell you about. All of this helps you narrow in on where the key failures are likely to occur so that you can make sure you have access to the error logs themselves, but also the rate of errors is being tracked as some kind of metric. We also need to decide at what point we enter the service is no longer healthy territory so that we can set up an alert potentially or make sure that we have engineers who are intervening at that point in time. And we would ideally replace that alert though at some point with an SLO-based alert. I don't like the term traffic as much as I do throughput, but the point is that we want to understand the volume of stuff that our service is having to process at any given point in time. So in my context, this might be a volume of files or maybe the volume of service orders going through, rather than what I've been more used to in the past, the volume of HTTP requests or API calls or web page views. Having metrics on throughput is helpful to understand the volumes of load that your service is under today and to track how that is changing over time. It helps you to see seasonal changes. Loads will change at different times of the day, the week, the month, or the year. There will be long-term change as your business grows or shrinks. There could also be situations where a lack of throughput is a signal that something is broken. What if you have a job that runs every night, that processes around about 10,000 records every night, and then one day you happen to notice that the throughput is zero? There's no errors, they haven't occurred yet, but something upstream, maybe with a third party, and the raw files that you need to process were never delivered. It's a good idea to think about throughput in terms of successful and failed transactions as well. Successful transactions are the ones which will be making your service actually do stuff and process things, whereas failed ones often skip processing, which changes the resource consumption and the whole performance and behavior of your service. This is something I would frequently see in performance testing, specifically when a load test was running and you looked at the result and it looked fantastic and it could handle huge volumes of load very, very quickly, until it turns out that there were some hidden silent errors occurring. And all of that activity you were generating wasn't actually triggering any processing. And then when you fix that up, everything falls apart. Saturation is something I've been finding kind of challenging in the cloud native context. So in the past, we always use servers, virtual or physical servers, and there were always those 4 core resources to think about when it came to saturation: CPU, memory, disk, and network. And then I went in Kubernetes, where there was pod CPU throttling or host CPU and memory usage. And then there's Java applications and there's JVM heap consumption and CPU consumption at that level. But now I'm looking at Lambda functions and containers in ECS. I haven't had the time or the space to go really deep into these contexts and whether any concept of saturation makes sense for us to track or not. I'm guessing there are useful things that we should be tracking, but I need to do the research to build up some playbooks and understanding about that. I'd be keen for advice on this and would love a guest to come on Slight Reliability and talk about resource usage monitoring in the serverless or the container context. Not so much Kubernetes, because I think I know a little bit about that, more ECS or some other more abstracted way of running containers, or serverless in particular. So those are the 4 golden signals, but I also wanted to talk about availability. The 4 golden signals are great, but there's one more slightly more abstract question I want to answer for any given service. How available is it? And like anything else, what availability means depends on the context. For the async processing context, I'm leaning towards the percentage of availability equaling the total number of successful transactions divided by the total number of transactions. Because we're talking about an almost data pipeline context here, there might be a better way to articulate this than availability, but this is what I'm using for now. And again, I'd love to hear your thoughts on that terminology or the approach to thinking about availability in this context. The benefit of defining availability is that at the very least, you can start to measure it. There's something powerful about being able to quickly and decisively report back on the availability of your services. It's even more powerful to show that how it's changing over time. And then if you can take that and have a conversation with your business or your leadership about how available they'd like the service to be, then you're well on your way to implementing SLOs. There's one final thing I've been thinking about. It's potentially worth looking at upfront, which is cloud spend. For any given service, if you capture metrics about the daily financial cost of the cloud infrastructure and usage, it could save you a lot of grief later. You don't want to be caught unawares by unexpected huge cloud bills because you just weren't aware of what the actual consumption is at a financial level. But mostly I wanted to say that the purpose of this work that I'm talking about here is to define some kind of repeatable template to discuss and define the signals that accurately tell us about the health of our services, to give us confidence that a service is running as intended, and to lay the groundwork for more complex observability or service level objectives at a later date. Most of all, I see this as something that requires very little dependency to implement. And the more agency that you can give SREs early on in the implementation of SRE to just get on and do work like this, the faster you can make things happen and the earlier you'll be able to see results across your organization, get your SREs motivated and excited about what they're doing. So that's all from another episode of Slight Reliability. I hope you've enjoyed this solo episode packed with real-world experiences. I don't have any guests lined up for the near future, so please reach out to me if you'd like to talk about your experiences in the world of SRE or operating complex software systems. My only caveat at the moment is no AI. There's plenty of other mediums to talk about that all over the internet, Slow Reliability is a place where people in this field talk about their experiences and how they overcome challenges and how they interface with the technology that we work in every day. And also, if you want to be a guest on the show, please don't send me a ChatGPT written email because I won't respond. So sorry for the 24 or so people I've literally just deleted and blocked emails from already. I just don't like reading that, and I don't have time to engage with that. I just want to talk to a human being. So thanks for listening in once again, and I'll see you all next time.